Good morning. Oh, how are you guys liking the show so far? Thank you. I have the pleasure to open and conclude today's sessions in this room. So you can just stay asleep after this one, and I'll wake you up when I'm done at 5. Many thanks to our sponsors who are making this possible year after year. Special thanks to Semperis, who also happens to be my employer, which is not why I'm here. I was selected to speak before I was at Semperis. My name's Evgenij. I'm from Berlin. I must keep living in Berlin unless I want to redo my whole social profile. Twitter, X, my blog site, and so on. It all has Berlin in there. So I work, as I said, at Semperis as a senior workarounds architect, which means solutions architect, which means I get to code PowerShell a lot, despite being in pre-sales. I'm a Microsoft MVP for another week. We shall see what the 1st of July will bring in the cloud and data center management category, which 4 years ago more or less was PowerShell. Now PowerShell got its own category back. We shall see. I've been doing computers for upwards of 30 years. Big part of that in the Microsoft corner of the world. And I've attended all the PSConfs so far that were held under this brand, spoken at some of them, and so on and so forth. So before we decide what we're going to do in this session, let's have a quick show of hands, because we had 2 excellent sessions yesterday on topics that are directly connected to this one. Who of you were in the session yesterday by Jordan Borin, where he unpacked the innards of PowerShell remoting? Great. And who of you attended Ben's session on managing everything with SSH? Thank you. That is a good quote. So some of you might learn something new today. This is usually not my want. I tend to start my sessions with a disclaimer that nobody is going to learn anything that they hadn't known already. But let's see. So in this session, we will not be talking about the primary use case or the oldest use case of PowerShell remoting. We will also not be talking about accessing APIs, REST APIs or web service APIs from PowerShell, because that is not what this session is about. What we want to talk about is basically connecting to a remote machine and running commands on that machine under special circumstances. I will explain in a couple of seconds. Then we will talk about that legacy thingy Jeffrey Snover was hired to make better with questionable success, and some other stuff if we have time. I tend to go over time in my talks, so I took utmost care to not pack too much into this session. Let's see how that works. So the example everybody was using for as long as there was PowerShell was I connect to a different machine, in this case interactively by enter PS session. And the reason why that works is that the client machine and the server machine I'm connecting to are both part of the same domain, or of trusting Kerberos domains, and Kerberos provides both authentication and encryption along the way. WSMan and WinRM are both happy, so nothing new here. This is not what we're going to be talking about today. As you heard, or at least those of you who attended a talk of Justin Grote last year, or the one from Jordan yesterday, PowerShell 7.3 onwards allows you to create your custom transports. More or less, they had this private API all the time, and they just made it public so that everyone extending PowerShell is able to use that. You can utilize whatever technology underneath. So basically, you would be able to build a custom transport on top of that functionality that also allows you to connect securely in an untrusted situation. But this is not what we're going to be talking about today. So, 15 years ago, everybody, at least in the corner of the world where I was consulting, everybody was trying to put as many, at least Windows-based systems into Active Directory to provide that common authentication, authorization, lookup facility that Active Directory helps us provide at the cost of hackability and generally diminished security, which is why Semperis is doing very well, because that's what we do, Active Directory security, and this topic will stay hot for the foreseeable future. But the first thing that people came up with was, okay, let's pull some systems out of Active Directory and make them untrusted. Backup systems, monitoring systems, all those sorts of systems that do access tier 0 systems with high privileges, becoming tier 0 systems by definition, by virtue of that access, but not deploying in a trusted forest, not deploying in any forest at all, but deployed as a workgroup machine or in an untrusted Kerberos realm. Cross-platform automation. PowerShell 6 brought us Linux compatibility, so we could come up with the crazy idea of managing Windows from Linux or Linux from Windows, things that were unthinkable before, and still have to manage authentication, lookup, and authorization somehow. What that means is we don't have implicit trust. We always have to use explicit authentication of some kind. It's either a Windows system, which is in a workgroup configuration, then we would probably be authenticating to it using local accounts from that machine, or it is an untrusted or untrusting forest. Then we could use domain credentials from that forest. Or maybe both machines are standalone, so we don't have any authentication facility in either world. And which also tends to be the case in these untrusted deployment scenarios, is that we don't have DNS, at least in those areas that are outside of Active Directory or another Kerberos implementation, so might end up having to access machines by their IP address and so on and so forth. What we also have in an untrusted scenario, in a modern scenario, is a hardened attack surface. So people start actually using Windows Firewall and using their data center firewalls to full extent and actually closing ports and shutting down services because consultants doing pen tests, doing security assessments have been telling them to do that for 20 years. Right? I recently found a piece of communication from 17 years back where I told people to fucking shut down the spooler service on their domain controllers. We didn't have printing nightmare back then. We did have that, but we didn't know that yet. So nothing of this is new, but right now, due to ransomware, due to those killware attacks and heightened security awareness, people actually start doing this stuff so that in an untrusted scenario, you might end up not only not having a common authentication basis, but also not having all the protocols at your disposal. We had this discussion yesterday in the keynote. New and shiny. PowerShell 7, VS Code. I'm one of the 17% who still code for PowerShell 5 using ISE. I do use the other stuff, but this is my primary driver because living off the land may prove life-saving in some sort of circumstances, especially if you're in a high security environment. You can't just install random shit from GitHub on the customer's machines, even if it's signed by Microsoft. You need to cut through red tape that is thicker than your whole project binder. So, installing additional components might prove tricky. Changing the target machine configurations to enable your untrusted access might prove impossible, or at least not possible in the time frame of your engagement. And changing that at scale might be the snake that bites itself in the tail, because to change that at scale, you need that management that you are trying to establish in the first place. Opening standard protocols, like if someone actually closed down WinRAM on the environment, opening it back up to enable tier 0 untrusted access might prove counterintuitive and also not be allowed in certain organizations. Changing source machine configurations is usually sources from where you are trying to manage a target machine or a collection of target machines. That might prove less challenging, but still, if you don't have like local admin rights by default, you might not be able to create source configurations that are needed to use protocol A, B, C, or D. And of course, we are all busy. We are also all lazy zones. Otherwise, we wouldn't be into automation that much, right? And since we are lazy, we want to have as short a preparation for our remote access as humanly possible. So, what are our use cases? If we had like 4 hours, we could go through every one of them. But so the primary use case, like I said, is two machines that trust each other by virtue of a common Kerberos realm. Not talking about that today, but managing such machines from an untrusted workgroup machine is one of our use cases. Managing another workgroup machine from an untrusted workgroup machine is a different use case that we would have to cover. And then, of course, there is also the possibility that we end up managing workgroup machines from inside a Kerberos realm. And then, of course, since we are all cross-platform, new and shiny Linux, and I apologize to Macintosh users, everywhere there is a penguin in this presentation, we do mean Mac as well. I'm just not that into fruit. So Linux comes along. So we might have to manage Linux from Windows, or Linux from Linux, or Linux from Windows from Linux. Windows being part of a Kerberos realm, or Windows being standalone, and so on and so forth. So this is a lot of, there are a lot of possibilities here, and we will not go through all these use cases, but for each use case you encounter in your scripting, in your administration, you have to ask yourself two questions. What are the possibilities that are open to me to enable that management along one of these arrows? And the other question is, what is the operational cost? This also goes in the direction of living off the land, because if I tell a certain customer of mine they have to roll out PowerShell 7 to 10,000 Windows servers so that I can manage them from Linux, I will probably not get the next engagement. So, how do we do WinRM without Kerberos? So we are now at those errors where Windows is at both ends. WinRM only works from Windows to Windows, but it works in an untrusted scenario. There are two possibilities to make that happen, because what? We have to protect credentials, right? So if we don't have a Kerberos ticket to take care of authentication from target to source, we have to pass on credentials, and those credentials have to be protected. And this can be done in one of two ways. You either enable HTTPS for WinRM on target. On target, we're talking about configuration at scale. So if you don't have that in place, you have to have that in place. And not only have you got to deploy certificates everywhere, you also have to deploy the WinRM configuration with an HTTPS listener. There is nothing fancy about it, but it has to be done. And the source, which is not trusting the target for authentication, must be configured to also trust that certificate. And then we have the DNS problem. If the source doesn't have the DNS resolution to the target, they will not be able to supply the FQDN that the certificate is listening on, or the WinRM listener is listening on. So the certificate validation will fail. So DNS, I didn't list it here, but DNS is also a prerequisite of this, because that is not easy to do in an enterprise setting. There is another possibility. WinRM will happily use CRED SSP and credential delegation and all those things we've been telling people to avoid for 15 years. For that, the source, the machine you're managing from, must have this configuration, an entry in trusted hosts for every target. And people who are looking at every target, meaning 10,000 servers, tend to put an asterisk in there in the trusted host. I'm seeing it every other time I look at this configuration, which means you basically agree to give your CRED SSP protected credentials to anybody, to any machine you are coerced into connecting to. So not a very good proposition, but depending on where you are in the whole food chain of that organization, whether you actually have a say in what happens on the target machines, or whether the source machine is the only one that you have any control over, you also need local admin rights to create this configuration, by the way. So depending on that, you might be compelled to go that road, right? So, and I know that it's called root in English, in proper English, Mr. Leach. I just happen to work in an American company. So, everybody starts talking about SSH remoting as soon as Kerberos is not an option, and SSH is possible between all of those endpoints that I had on my slide. Let's see how that is defined. So we have SSH remoting for all the remoting commandlets, not only enter PS session, but I'll be using that in this presentation, but also for invoke command and so on. Everything that uses remoting in PowerShell 6 and 7 has the host name parameter, and the host name parameter, as opposed to a computer name parameter, indicates that we will be using SSH. So what we do not have, we do have username here, and depending on whether we are connecting to Windows or Linux, you have to stick to a certain format for that name. You can also use just the username if that's identifiable. But what you don't have in this parameter set is password, or even secure password. So the username and password authentication over SSH will also always be interactive. Which means if you're trying to provide some sort of automation, you need zero-touch remoting. Zero-touch remoting will require a key file. The user generates a key file, saves the public key into the authorized public keys on the target, and you get the private key, which you supply as a part of that connection. Which means for zero touch, you're not allowed to protect the private key by password, because then the password again would have to come from somewhere, and there is no parameter to provide that. And you absolutely need to have the correct permissions on key files. And SSH helps you with that. Let's look at some demo. So, first order of business, I have this is my client machine. This is where I am logged onto is my source machine. One of my source machine. I also have a source machine under Linux. This is a WS01, the Windows machine, and Linux is LX01 and LX02. So I have my target server, which is MS01, and on that target server, I have some users. I have apparently Alice who logged onto this machine. I have Craig. I don't have Bob. And this is for a reason, because the user Bob, which does exist in AD, is not allowed to log on to that machine. User rights assignment. Bob is not allowed to log on as a badge. Bob is not allowed to log on as a service, not interactively, not remote interactively. So Bob can't log on to this machine. Bob also doesn't have any permissions on this machine. But let's see what happens if we try to remote in as Bob from Linux. We specify a host name. On Linux, we don't have the WinRM option with computer name. PWSH. So I'm asked for Bob's password. Et voila. So, if this is the only thing you learned in this session, I think it's more than enough. SSH remoting allows you to bypass your logon restrictions of any kind. The only thing that would work is deny access to this computer from the network, but that might not be what you envisioned, because if that computer is a file server, then Bob absolutely has to access that from the network, just not on this protocol. And as you can see here, and as you can also see here, it even creates a user profile on that machine for Bob. So, not very secure in terms of Windows logon restriction. So let me do a quick exit here. But I also have that user Craig, and Craig created his key file on the MS01 machine. Craig is allowed to log on there. I can't use PowerShell, Windows PowerShell to try that, because I have to have PowerShell 7. But if I try to log on, then yes, I should be able to. So I'm obviously able to log on as Craig using key file authentication without any further interaction, which is good. It's also really Craig. And I only specified the username here. It was enough in that scenario to map the username to the profile of PSConf /Craig, who had that key file in their profile. But, and this is just a quickie, it's not part of what Linux does. It's just not been configured properly, but I wanted to show you that Anyway, if we try the same thing from this LX01 machine, I do have the file on there, by the way. I get a warning. I get a warning about an unprotected key file. So SSH helps us to not overexpose those keys. Now, I misspoke. SSH will not use an underprotected key file. It does not prevent us from underprotecting it in the first place. So we could place a Craig's private key, completely unprotected, world readable on that machine, but SSH would not allow us to use it for remoting. And it falls back to password authentication. Good. So here, short smackdown for you to take a photo if you like. Main differences. Paul Broadwith did a session last year, I think, about this. So there are some advantages and disadvantages to either technology. From my point of view, not having GIA over SSH is a very big disadvantage if you're remoting to Windows. But, well, your mileage, as always, may vary. So, what else is there? I announced that already. We will be talking about that Jeffrey Snover was hired to do better thingy that Microsoft finally deprecated in the upcoming version of Windows. But first, before we get to that, let's look at using SSH not for PowerShell remoting, but for what it is, for just SSH. There is a great module, Posh SSH by Carlos Perez, who used to come to the PSConf a lot, which unfortunately has changed in the recent years. It's a wrapper for rinsing, but beautifully done, very stable. I use that at scale to manage like hundreds of Linux machines from a Windows machine. And you can supply commands. It also does SCP. It also does SSH streams, and so on and so forth. It's very PowerShelly. Nobody has any differences getting to terms with that. You have to take care of two things. Timeouts if you have long-running commands. And if you need sudo on the target, you'll have to specify the password in clear text. Put the space that you may see here between the quote and the echo is intended. This prevents most Linux distros from putting this command in the logs. But over SSH, you don't have a terminal session anyway, so logs usually will not be created. But I've seen that happen, and by doing this, you are able to prevent the password being exposed in the command history, basically. You can also do SCP with these modules, command streams, which is a very, very powerful but very hard to implement functionality. So great stuff if you have to manage Windows machines. I did not find it as useful for Windows, because towards Windows, if you have SSH already configured, you could just use Windows remoting. But to configure SSH remoting for PowerShell on either platform, you have to reconfigure your SSH daemon configuration to enable the PowerShell subsystem, which is not done by default. That it's not even done by default on Ubuntu if you install PowerShell that they include in the mainstream distribution. So again, reconfiguration of target machines at scale. If you can do that, you're lucky. If you can't, you can at least do SSH in its original form. If you have PowerShell installed on the target machine, and you have SSH to target, but you don't have the PowerShell subsystem configured for SSH on target, you still can SSH into the machine using posh SSH, and then start local PowerShell there and still use PowerShell, but it's of course not a very comfortable sort of remoting. So this thing, WMI and or SIM, I was a proponent of WMI over SIM for a long time, and I still am of sorts, despite everything that's been written about it in the recent years. Because if you don't know that you can configure SIM to fall back on DCOM, you end up using WinRM. So if you start using SIM commandlet without this option, you are down to the same restrictions as using PowerShell remoting. You either need HTTPS for WinRM, or you need trusted host and credentials delegation. This allows you to fall back to DCOM and use the protocol that WMI use and that the WMI commandlets will use. But there is still an advantage to using the SIM commandlets, because the SIM commandlets work with sessions. You do all the DNS lookup, authentication, negotiation, and so on and so forth, and buffer provisioning on target and on source once, and you reuse it, which makes DCOM session in SIM faster than WMI. In some scenarios, it's much faster. In other scenarios, it's not very much faster. Let's have a look. And by the way, if you remote into a Windows machine using SSH with an account that has local admin rights, you get an elevated token in that session. If you remote into Linux with an account that would be able to do sudo, you still don't get into sudoers. You still have to work around sudo. So, doing the same thing many times. So basically, just pulling the Win32 computer system 1,000 times is much faster on using SIM commandlets and a session than using WMI and setting up the connection every time. It takes like half a minute. And I will use this time to show you what happens in the second part of the script. Here we just list all the services and then pull the object for each service using WMI or SIM over DCOM. So 1,000 times the same thing, took 20 seconds over WMI, and 8 seconds using SIM over DCOM. Over DCOM, we don't have trust between target and source, so we are down to DCOM for the duration. So how about we do a service enumeration and see how that works, and I will spare you redoing the same in PowerShell 7, because there doesn't seem to be much difference in performance there. Despite what they're telling us that PowerShell 7 makes your scripts run 20% faster by magic, this does not happen in this particular scenario. And the WMI command list, the native command list from 5.1, actually runs slower, because 7 has to do an implicit remoting to the 5 subsystem, because 7 does not have those command lists natively. So, enumerating all the sessions using WMI remotely on a machine that is running on the same host took us 31 seconds. Let's see how SIM over DCOM fares. it's basically the same time. Right? So there is, if you're not allowing the host to cache, if you're not allowing the client to cache by actually redoing the same query over and over again, you don't get much in terms of performance out of SIM. But they told us to use SIM, and SIM is native on PowerShell 7. So this is the compatible option. I never thought it will come to that I will say that something that is native to 7 is a compatible option, but in this case it is. So WMI allows us to do crazy things. We can, for example, read registry using WMI. Remotely, using explicit authentication with name and password to a machine where there is no trust, where there is anything else, nothing else in between that would allow smooth remoting. I mean, reading remote registry is not a trivial task, even in PowerShell, right? Because the PowerShell drive registry is local only. But in this case, we can use WMI remoting if that is allowed by firewall. I probably mistyped my password. Yeah, here we go. But I don't. Okay, I have a break in here. But with the session I just established, I can provide the value, which is indeed the name of the Hyper-V host that I read from the registry of the guests. This is the name of my laptop. So there are lots of stuff that you can do with WMI. I can offer a crazy example here. Recently, I had to enumerate the native audit policy. So effective audit policy in effect on domain controllers of an organization that has operating systems in like 10 languages installed throughout the world. The problem with that, and bad connectivity to some of the locations as well. The problem with that is you also can use audit poll for that. And audit poll will provide nice CSV sort of output. But the very value that you're looking for, namely the policy in effect, it will give you the goods for the actual policies, but the value that is set for each policy is provided in the language of the operating system. So you have to map that. To not have to do this, we did the following thing. We used the Windows API, embedded that in C#, embedded that in a script block. And for that script block, the only problem was getting the results back. Because if I invoke processes on the remote machine using WMI, I don't get the output, like the standard output, because I get a result the moment the process starts, not when it ends. So what we ended up with is just export the policy into JSON, compress it, write it to registry value, and then read that registry value again by using WMI without trust between the source and the target. And what we do is we encode the command as base 64 to take care of all the squiggly braces and thousands of quote marks that are in that source code. We just drop it into a base 64 blob and start the process using WMI or SIM in this case, but falling back to DCOM to generate that data. And I also have a connection to the DC here. Let me open this up. You will not be able to see much because I can't make the font larger. So as you can see, there are no values under the HKLM software key. But if I were to start this and authenticate using my password, I did start a process on the DC, as we can see, with a return value of 0, which is good. And a couple of seconds later, I have the PSConfEU.audit policy key here containing my nice JSON with numerical values of those policies that I can analyze at scale. So, one last thing. So that were the WMI shenanigans. What else is there? If WMI doesn't work, if you don't have remoting and don't have the permissions to configure that, either in source or in target or both, so many services can run executables. And you might, due to the nature of your engagement in that particular infrastructure, end up being able to abuse these things. And more often than not, I've been doing Active Directory security assessments for over 10 years. More often than not, those services end up running in privileged contexts. Let me show you something. I have a nice function here. I will not disclose it to you just yet. There is a function invoke remote shell. Let me just load it into the session, but I will show you what it does. So, I would like, as you remember, we are on the machine named WS01, PSConf-WS01, and I'm connecting to MS01 and running hostname on it. So, we are apparently doing stuff against that machine. And this is the interesting part. We are obviously able to run in the system context of that machine. But what are we using to get there? And this is from an actual engagement. This has been used in production to save the day after someone accidentally closed down any remote access to that machine. There was no remote access whatsoever to that machine, and it was in a cloud data center, so you couldn't just go out and get at the console. So what we ended up doing, we abused the SQL server that was the purpose of having that machine in the first place, and where we, due to the nature of our engagement, had SH rights on. We could enable, I didn't provide that here, but we could enable the XP CMD shell extension and use the CMD shell extension to actually run the command. Be creative. If all else fails, the hacker do that too. They are also living off the lands. They are also finding ways to remote manage your system. Why shouldn't you remote manage your own systems in ways that Microsoft did not think of providing for you? And that, ladies and gentlemen, brings us to 1 minute of Q&A. Are there any questions?
Regarding the login with the denied interactive and remote login user, what will be the security context for that? Will that be also then keep authoritative?
The question was, the Bob user from the first example who was denied all possible login right, what would be the security context? No, the security context would be Bob. There are processes actually starting in the security context of that user despite all the policy restrictions that have been put in place. You can't elevate. You just break through your logon restriction. It's not an elevation technique, but it is sort of a lateral movement technique at that point. Anything else? Then I will make place for the next speaker. Thank you very much.